Hello world. I'm Imagination. Today I'm going to talk about quantum computing. Quantum computing is the use of quantum mechanical phenomena such as superposition and entanglement to perform computation. Computers that perform quantum computations are known as quantum computers. Quantum computers are believed to be able to solve certain computational problems, such as integer factorization, which underlies RSA encryption, substantially faster than classical computers. The study of quantum computing is a subfield of quantum information science. Quantum computing began in the early 1980s when physicist Paul Benioff proposed a quantum mechanical model of the Turing machine. Richard Feynman and Yuri Manin later suggested that a quantum computer had the potential to simulate things that a classical computer could not. In 1994, Shor developed a quantum algorithm for factoring integers that had the potential to decrypt RSA-encrypted communications. Despite ongoing experimental progress since the late 1990s, most researchers believe that fault-tolerant quantum computing is still a rather distant dream. In recent years, investment in quantum computing research has increased in both the public and private sectors. On October 23, 2019, Google AI, in partnership with the U.S. National Aeronautics and Space Administration, NASA, claimed to have performed a quantum computation that is infeasible on any classical computer. There are several models of quantum computing, including the quantum circuit model, quantum Turing machine, adiabatic quantum computer, one-way quantum computer, and various quantum cellular automata. The most widely used model is the quantum circuit. Quantum circuits are based on the quantum bit, or qubit, which is somewhat analogous to the bit in classical computation. Bits can be in a 1 or 0 quantum state, or they can be in a superposition of the 1 and 0 states. However, when qubits have measured, the result of the measurement is always either a 0 or a 1. The probabilities of these two outcomes depend on the quantum state that the qubits were in immediately prior to the measurement. Computation is performed by manipulating qubits with quantum logic gates, which are somewhat analogous to classical logic gates. Quantum computers could spur the development of new breakthroughs in science, medications to save lives, machine learning methods to diagnose illnesses sooner, materials to make more efficient devices and structures, financial strategies to live well in retirement, and algorithms to quickly direct resources such as ambulances. It's time. Quantum computing is going from something that's theoretical to practical. And it's on its way to having a real impact. A new partnership between Microsoft's Azure Quantum and Honeywell offers another way for organizations across the globe to be introduced to quantum computing. The era of quantum computing is just beginning, and we are looking forward to bringing that capability to a broader audience, said Tony Utley, president of Honeywell Quantum Solutions. Computers traditionally use bits to process information. But quantum computing depends on bits that have properties of quantum physics, called qubits. Traditional computing bits are either 0 or 1, but qubits can be in both states at the same time, a quantum property called superposition. Another quantum property, called entanglement, allows for qubits to be quantum mechanically connected to other qubits in the system. As a result, quantum computers leverage entanglement and superposition to solve previously impossible computational problems. Quantum computers will disrupt current techniques and solve previously unapproachable problems, creating valuable solutions for industry. For example, pharmaceutical companies could accelerate the discovery of new drugs, materials companies could discover new molecular structures, finance companies could develop new trading strategies, transportation companies could optimize logistics, and companies relying on the output of the machine and deep learning could perform analyses that are impossible with classical computing of today, Tony said. Consider a few more industries that could benefit. Airlines seeking the optimal way to store spare parts at airports. Distribution centers wanting the best way to maneuver robotics around a warehouse. Oil and gas companies calculating how atoms and molecules can be configured to protect equipment from corrosion. Ideal answers to these problems across industries could be found through quantum computing. Quantum computing will enable industries to tackle problems they never would have attempted to solve before. And the quantum computing market is projected to grow strongly through the next decade, according to a Tractica market report. Wide access is important as quantum computing makes its way into solving mainstream business problems, Tony said. Microsoft's Azure Quantum Platform provides another path for making sure we reach a broad audience. That's all for today. Thanks for watching.